So extending that idea to the case where you have one regressor, like the idea that we are going to multiply the probability of what happened is the same. So we are going to maximize the probability that what happened. And when you have a regressor and when you have the probing model, then the only difference is that the probability is calculated according to the model. The model specify how the probability is calculated depending on x. So that's how we calculate the probability. For example, probability that y equals to 1 given x 1 is given by this form. So remember, beta 0 plus beta 1x is the z value, and we take a nonlinear function phi of that linear value. This is the probability of 1, and then automatically probability of 0 is 1 minus the probability of 1, because the outcome is either 0 or 1. The sum of these two probabilities must be 1 all the time. So therefore, so these two different cases can be written in one equation this way, so using exponent of y or 1 minus y. So then now you are going to multiply these probabilities from the first observation till the last one, to n. So there are n observations, n number of observations. So you multiply all of them. This is the likelihood function for the probing model. So it's a likelihood function because this captures the probability of what happened. And similarly, if you take log on this likelihood, then you may simplify the algebra. Anyhow, the idea is to maximize this. This is how much you win. To maximize this, you have to choose beta 0 and beta 1. And algebraically, it's possible. You just need to differentiate and find the first order condition and make it equal to 0. And then anyhow, that process is done by stata. It's automatically calculated. So you do not need to know how to find the maximum. And then the result is important. It is really good. That's the simple conclusion. So in the large sample, if the sample size is large enough, these MLE estimators are consistent. It will converge to the true parameter as the sample size converges to the infinity. And they are normally distributed. Sampling distribution is normal, approximately normal as n goes to the infinity, and they are efficient. This is really strong outcome. It is the most efficient estimator, which is a theoretical result, but usually this guarantees, so it is consistent, normal, and efficient. Almost in all dimensions, the MLE is the best. So it's really powerful and strong results, and shows the MLE is theoretically the best estimator. And standard errors will be computed by automatically. It requires a little more derivation, which I'm going to skip. And then, given the standard errors, all the methods can be applied in the same way, like hypothesis testing, confidence intervals, how you calculate the t-statistic, how you calculate the p-value, how you calculate the confidence intervals. All of them are exactly the same, can be done in the same way as the OLS method. So simply speaking, there is no difference once you get the result. So unless I explained the difference in interpreting the results, but technically there is no difference because all of the methods are based on normal distribution approximation and standard errors. These two key foundations are basically the same for the OLS or for the MLE, so you may use the same method again here. And if you have the Login model, the idea is identical. The only difference is the probability should be calculated using a different nonlinear function. The nonlinear function is a little bit different, but nearly identical to the probing model. Anyhow, you are not going to write down the equation, so it's done by theta. So you just need to understand the idea. The idea is it's good. all the nice properties hold in the same way because it's also the MLE estimator under different assumptions, and then there is no problem. You may use the same methods, and you may just assume that your estimator is the best possible. And then, but the difference here is there is a difference. A key difference is that R squared is not applicable in the same way. The main reason is the outcome is not continuous anymore. So as I explained earlier, so if you observe something happened and you estimated the probability as 90%, that means you did really well, but there is still a 0.1, 10% error. The problem is this error a real error or not? I would not interpret that as an error. Instead, I would interpret like, so if something happened and you estimate it as 90%, then you like literally you gained a point of 90%. So you are correct with 90%. So we would interpret that as the fraction correctly predicted. So this would be a better way to understand. So if the predicted probability is greater than 50%, then you're good. Then you correctly predicted. Otherwise, not. And then you compare how many of the actual observations you correctly predicted. So counting the fraction is another way to measure the fit, how the model fit the data. Alternatively, you may use pseudo R squared. This is different from the R squared. It's similar, theoretically similar, but calculation is quite different. It is based on the log likelihood. So we are maximizing the likelihood, right? So the larger the likelihood becomes, then the better the model is. So pseudo R squared is based on that idea. So how large your likelihood becomes. So and in some cases it is called pseudo R squared because in linear model pseudo R squared is equivalent to the standard R squared. Therefore, it's named as pseudo R squared, but it is not based on the residual. The residual, and remember, compare R squared. So in the OLS model, we are minimizing the squared residuals. So R squared was a natural way to measure the fit. However, now we are not minimizing the squared errors, squared residuals. Instead, we are maximizing the likelihood. Therefore, what corresponds to R squared would be something related to the likelihood. So that is pseudo R squared. So what you are minimizing or what you are maximizing would be a natural way to evaluate how good you are doing. If you are minimizing something, the smaller the better. If you are maximizing something, the larger the better. So the main idea behind R squared and pseudo R squared is related to maximization or minimization problem in the estimation. So in the next video, we will look at the real application of the profit model to the mortgage approval. So it will be an interesting example, and I'll continue that in the next video. See you later. Bye.